So one of the things we've seen before, you had it on your quiz that you just got back, is sometimes you're solving equations that don't just have one function. We had an equation with a cos and a sine squared on our last quiz. And we had to use sine squared plus cos squared equals 1, which is an identity, in order to change it so that when solving we only had one trig function. The same thing's going to happen now in identities. In this first equation, we're asked to solve between 0 and 2 pi, and we have 2 sine x equals 3 plus 2 cosecant x. Right now, we have two trig functions that are different. But if we can use an identity to have only one trig function, then we're going to be able to solve this. The other thing that we have to be careful on once we get to these questions is the key words in the question. There is a big difference between solving and proving. Proving is when you draw the line and you want to show the two sides are identical. Solving is where you want to use your skills in algebra to figure out what x is. This one cannot be proved. 2 sine x is not always equal to 3 plus 2 cosecant x. There's only specific points where it's equal. In an identity, it's always equal for all angles. So if it ever asked you to solve an identity, you'd have to say, yeah, every angle works. And then it would be confusing. This one, there's only going to be a couple of angles that will work. So first of all, can we change this so that there's only one trig function? What could we do? Yeah, we could change cosecant. We could change cosecant to 1 over sine. I'm going to put sine on the bottom because this is another good question to ask. What should I put on the top? Where does the 2 go? Does the 2 go down with the cosecant, or does the 2 stay where? Yeah, where does it go? Should this be 1 over 2 sine x, or should this be 2 over 1 sine x, or should this be 2 over sine x? What should it be? They're not all the same. This one has a 2 on the bottom, this one has a 2 on the top. Okay, so this one has a 2 out in front. I'll tell you 2 of these are the same. Second and the third one are the same. Because if I have a 2 out in front and I'm multiplying, that means a fraction like 2 over 1, right? Okay? Now, of these 3, I hope that you can see that this one with the 2 out in the front matches the most with that one to begin with. Because this is 2 times cosecant, and cosecant's 1 over sine. So when I write this as 2 times 1 over sine, that should make sense that that's the right one. Now you notice that this 2 is 2 over 1. That's the same as 2 over sine x. This one is wrong. All right, so let's erase here and write it out correctly. The big thing to notice here is that 2 does not move to the bottom of the fraction, because cosecant is 1 over sine, only the sine is at the bottom. And now we have to solve this. Solving this question is just like solving questions that you had in the past where x was on the bottom of the fraction. So if you're wondering, how do I solve this? You can take sine, replace it with x, just to jog your memory. What would you do if you had to solve this equation? How do you solve that? What kind of equation is that? You remember the name of it? It's a rational equation. How did you solve rational equations in grade 11? With the help of my friends. No? The fraction causes problems for people, right? So what do? Get rid of the fraction. How could you get rid of a fraction? Right? How do you get rid of a fraction? What's the opposite of dividing by something? Multiplying. So if you multiplied everything by x, the fraction would go away here and you'd get 2x squared equals 3x plus 2. But we don't have an x now. What are we going to multiply by to get rid of the fraction? We're going to multiply by sign. So you can multiply this one by sign, this one by sign, and this one by sign. Because what you're doing is you're multiplying both sides by sign. And when you multiply the right side, the whole right side by sign, it gets distributed to each term. So what does that give us? That's going to give us 2 sine squared x equals 3 sine x plus, and here, the signs will cancel, and we no longer have a fraction. So we went from a rational equation, which should have jogged our memory and said, I know how to solve a rational equation. I have all those skills. Now we look at it. What kind of equation is it? Quadratic. How do we solve quadratic equations? Make one side equal to 0. So everything you've learned in the past comes back at different parts of the equations. And then you have to be able to say, I know how to solve that part, and move forward. So now how do we solve this? We're going to need to factor. And if it's going to be factorable, it's going to have to start with 2 sine x and sine x. In order to get 2, you're going to need 2 and 1. So it's either going to be 2 and 1 or 1 and 2. Can you see right now that the outside is 4, the inside is 1? That makes 3. If the outside is negative 4 and the inside is positive 1, I'll get negative 3. This side, sine x is equal to 2. This side, sine x is equal to negative 1/2. 1/2 on your pie plate. Pi over 6 family. What quadrants? 3 and 4. So you'd have 7 pi over 6, 11 pi over 6. There's 2 on your pie plate. Not possible. Because it's bigger than 1. This side is not possible. So now we solved it between 0 and 2 pi. You can feel really good. You might go on to the next question, but you always have to go back to your original question because you get, like we did a lot of stuff. What was our original domain? It was between 0 and 2 pi. So we know we're done. But you always have to check that at the end to make sure it wasn't a general solution. You don't have to add 2k pi. We don't have to go from negative 2 pi to 2 pi and do the negative ones as well. So we're always checking our domain at the end. Nice. That was equation number 1. Part B. Sine x is equal to cos x. 2 ways you can solve this. 1, maybe you just know. Anybody have an idea from just knowing where sine x is equal to cos x? Pi over 4. From your unit circle, you know it's root 2 over 2 and root 2 over 2. Okay? A lot of students in pre-calculus don't like that feeling. Oh, it feels like I just guessed and checked. It's not really feeling like I'm solving. It feels like I did something wrong. So I should show my work. So there's a way to show this one too with showing your work using identities. I'm going to do it this way. First of all, I'm going to divide both sides by cos. That could be a little bit dangerous because I know I'm not allowed to divide by 0. When is cos equal to 0? Pi over 2. So if I do a quick check, if I plug in pi over 2 to cos, I get 0. If I plug in pi over 2 to sine, I get 1. Pi over 2 is not a solution. So I'm allowed to divide by cos because I'm not taking away one of my solutions. If I divide both sides by cos, would you agree that this is what I'm going to get? Okay? That might be helpful because, again, remember the strategy we used last time? We tried to write things with a single function. I still have 2 functions right now, sine and cos. I can change that to tangent. And now I only have a single function. Because sine over cos is tangent. When is tan equal to 1? Is that on your pie plate? Yes, it is. Pi over 4. When else? 5 pi over 4. So if you change it to tangent, I think it's easier to see the two answers. But you might have just known, yeah, I know at root 2 and root 2, they're the same. Also in quadrant 3, they're both negative root 2 over 2. So you might have thought of the 5 pi over 4 that way as well. So those are two answers that work. Okay, example number 10 is one you can do from this.